Hey guys, so we are going to be continuing our last note page in this video, and specifically we're going to be focusing on these four graphs, and we're going to be learning how to write an equation of a graph, because I know that you've been waiting for this your whole life. How can I write an equation of a graph? Now, these steps that we're going to go over kind of follow suit every single function we talk about. So when I say let's go ahead and write an equation of a graph for a square root or a cube root or an exponential function, we're going to be using kind of the same steps each time. They're going to change very, very slightly, but in general, they're the same. So it's really important for you to kind of understand the general premise of it so that you feel comfortable and confident, okay? So first things first is, if you look at step one, it says identify the 3 key points on the graph. So notice that all of these equations have 3 key points. Sometimes your graph will not have those 3 key points, and that's going to be something that you need to identify to start off with. Usually these key points are going to be at intersections, meaning that they're not going to be halves. Notice that G is a half. When you run into halves, what that just means is that we are going to probably have those labeled for you so that you know that those points cover on a specific half point. Okay, so that's step one. Step two is we're going to identify the middle point. Okay, so the middle point between your points. So the middle point, I'm highlighting all of them so you can see it's in between the 2 points. This middle point is super important for writing your equation of your graph because this point is your h and your k, okay? So literally what you see is your h for the first point and what you see for the second is your k, okay? So super important to label those because we're needing to know a, b, h, and k to write the entire equation of this function, okay? So we want to know our a, b, h, and k. So the middle point will always be your h and it will always be your k, okay? And the reason for that and why it's in the middle and not the sides is remember that when we look at our reference points, our middle reference point from our parent function is 0, 0. So anytime I multiply by the a or the b value, 0, 0 is going to stay 0, 0. So the only thing that will affect the 0, 0 is the h or k, and so that's why this is a reference point for our h and k values. So if you understand this, go ahead and pause the video and see if you can identify what is the h and k for f, g, and h. Okay, so hopefully you did it, and if you didn't, then maybe try on this next one. But basically, we're just going to label h and k for each of our points. What the numbers you see are going to be those points for your h and for your k values. So bare minimum, if let's say we were doing a test or something like that, I would want you to label these items. So maybe you were like, you know what, I don't understand how to write an equation, but I do get the h and k, Ms. Strickland. So what I would like to see is to get partial credit is I'd like you to highlight the specific middle point and label it as h and k so that I know that you're on the right track. Maybe you just couldn't explain the entire way through, okay? Now, here's where it gets a little bit tricky. What we need to do now is identify the A and the B. So we're going to take our 2 points, and we usually take the top 2 points, okay? So I'm going to just put a little table here for X and Y. So I'm going to put down the top 2 points. We have -3, 1 and -2, 0. So here's our top 2 points of our equation. And what we're going to do is we're going to see the difference between the y values and the difference between the x values. What I mean by that is how do I get from 1 to 0? Well, how do I get from 1 to 0 is I subtract 1, okay? How do I get from -3 to -2? I add 1, okay? And the y values are going to give you your a, and the b values are going to, and the x values are going to give you your b. Okay, now remember how I said that b is not going to be affected, so all of our b here's are essentially going to be +1, but I did want you to kind of know for future reference how to do that. So we're going to go ahead and do another example, and then I'm going to have you guys try the g and the h, okay? So let's label our little graph here. So again, our top 2 points are going to be labeled, and we're going to say, okay, how do I get from 1 to -1 for the y's? So 1 to -1, I have to subtract 2, so it's going to be -2. And how do I get from -1 to 0? I add 1, so that's going to be my b value. So my a will be -2 here, and my b will be +1. Okay, so I want you to go ahead and now pause the video and see if you can do g and h to see if you can get the right a and b values. Okay, so coming back, let's create that graph. We're going to take our top two values. So how do I get from negative 1.5 to negative 2? So negative 1.5 to negative 2 is a difference of a half. Now here's the thing is I put plus here, and I'm going to explain why I put plus, but technically this would be minus a half. And also the same with the negative 5 to negative 6, this would be minus 1 as well. Because we have two negatives, they will cancel out to give us a positive. Because remember, a negative and a negative times or division will give me a positive here. So there's no point in me saying that A is negative a half and B is negative 1, because essentially what's going to happen is those two negatives will end up giving me a positive. So I've changed them to be positive a half and positive 1. So if you had written negative a half and negative 1, just know that you were on the right track. But again, there's that rule that we want to think about, which is the negative times the negative, or negative divided by negative gives me a positive. Okay. All right, let's try H. So we're going to go ahead and put our top 2 points in here. And we're going to again do the difference between, or going from 6 to 5. And so again, it would be minus 1 here. And again, we have the 1 to 0, which would be minus 1. So same kind of premise as G. They're both negative. And so because they're both negative, we're going to change those into positives. So we're going to say a negative divided by negative is 1. So our A here is 1 and our B here is 1. So again, notice that all of our B values are 1. So essentially we're not going to graph the B values. So I'm going to write our parent function here without B so that you know what it looks like. So it's in the purple. So we have f of x is equal to a, and then the parentheses x minus h to the third power plus k. So we're going to keep the equation exactly the same, but the only thing that's going to change is we're going to plug in the a, plug in the h, and plug in the k. Okay? So here's the first one. So if we look at the, one thing to note, again, I took out the B. I just put that in the notes for you, okay? So here we go. So here's our first one. So we have f of x is equal to, our a is negative 1, so we're going to input the negative 1 for a, and then we have the parentheses x. Now here's minus h. Now notice that our h is negative 2. So if we had minus negative 2, same thing that we were talking about for g and h, a negative and a negative give me a positive. So I'm going to have plus 2 to the third power, and then I'm going to plus my k. Well, here's the thing, k is 0. So you could put plus 0 if you wanted, but you don't necessarily have to because it's not there. Now, a great way for you to double check and see if your graph and your equation are the same or correct is to use Desmos. So if I wanted to, I could type in this equation in Desmos and see if it pops out the same graph that I'm seeing on E. And if it does, then I know that I've done this correctly. So again, Desmos is an amazing tool for us to just double check our work and make sure that we're doing it correctly. Okay, let's try the next one. So again, it starts off with f of x equals, our a here is negative 2, and then our h is 0. So notice we're not going to have to put anything here, so it's just going to be x. Could you put x minus 0? Absolutely, but just notice 0 is nothing, and so you don't necessarily have to have it there. To the third power, and then our k is minus 1. So I would love for you guys to pause the video again right now and try G and H on your own. Can we do this? Remember, practice makes perfect, and so the only way for you to practice and solidify the understanding is for you to try it. So go ahead, pause, and try G and H. Okay, let's go ahead and see if you got it right. So let's check out G. So we have f of x equals, our a here is a half, so we're going to go ahead and put the half first. And then parentheses x minus our h. Notice again that our h is negative 6. So x minus negative 6. So two negatives here. It gives me plus 6. And then raised to the third power. And then we have our k, so minus 2. Did you get it? Hopefully get it. You did, and you feel really good. Okay, and then let's look at h, our last one. So we have f of x is equal to, our a here is 1, so you don't need to necessarily write 1 in. If you want to, you can, but you don't have to. I'm going to just go ahead with the parentheses. And then notice our h here is also 0, so I don't need to write anything in there. Again, I could put x plus 0 or x minus 0, and that would be fine too. And then our k is 5, so we're just going to put plus 5. So like I said, at any time, if you wanted to check any of these, you could go ahead and plug them into Desmos and see what your output would be, and you should get the same exact graphs that you see here. Hopefully this note was something that you feel really good about, but again, reach out to me if for some reason you really are struggling with this or you need any help. And that's it, and I'll see you guys in Zoom.